The National Institute of Radiation Protection and Research (NIRPR) was established as the technical support organization to the Nigerian Nuclear Regulatory Authority (NNRA) by the Nuclear Safety and Radiation Protection Act 19 of 1995. Section 11 of the Act gave the NNRA power to establish an institute to be known as the National Institute of Radiation Protection and Research for the purpose of carrying out its general functions under Section 4 of the Act. Thus, the NNRA established the National Institute of Radiation Protection and Research (NIRPR) and saddles it with the ancillary functions of the NNRA, which include training, research, and radiation protection safety services, etc. In the above regards, the institution provides essential technical services to the NNRA and authorized users for an effective implementation of regulatory program. The technical services include training services, calibration services, dosimetry services, analytical services such as environmental monitoring analysis, and wipe test and quality control services. Training services. The institute provides short-term practice-specific training courses 2 to 14 days for radiation safety officers in different areas involving exposure to ionizing radiation, such as nuclear well logging, industrial radiography, nucleonic gauging, transportation of radioactive sources such as air, land, and marine, radioactive waste management, security, industrial irradiation, oil and gas exploration and production, diagnosing and interventional radiology, nuclear medicine, radiotherapy irradiators and nuclear facilities, etc. The focus of the training is on technical and administrative framework necessary for protection against ionizing radiation and safety of radiation sources in relevant practices. The trainees are based on the approved International Atomic Energy Agency (IAEA) training syllabus for the radiation safety officers. The course program usually consists of lectures and practical sessions. Usually, examinations are conducted at the end of the course and certificates are awarded to successful candidates. The institute involves in the professional postgraduate diploma course in radiation protection and the professional master degree program in radiation protection run by Postgraduate College, University of Ibadan. The institute also conducts awareness training for radiation workers or any individual working and or staying around ionizing radiation sources.
The institute has secondary standard dosimetry laboratories (SSDL), which include protection SSDL, therapy SSDL, and diagnostic SSDL. The institute's SSDLs are traceable to the dosimetry laboratory of the International Atomic Energy Agency, a central laboratory of IAEA WHO network of secondary standard dosimetry laboratories. The SSDLs are the institute is operated based on ISO 17025 quality system. Calibration is done basically by establishing the dose rate at a particular point in the primary beam and then substitute the reference instrument with the instrument to be calibrated. Some of the major equipment at the protection SSDL includes protection level X-rays irradiator, cesium-137 and cobalt-60 gamma irradiator, thermometers and barometers, ion chambers and electrometers, check radioactive sources, water phantom. The SSDL protection calibrates about 500 radiation monitors per year. The monitors are mostly used in the oil and gas industry, earth and construction, etc. The monitors include surveymeters, contamination monitors, electronics, personnel dosimeter, personnel pen dosimeters, blippers, and environmental radiation alarm. As the diagnostic SSDL, equipment used is similar to that of protection SSDL, and it includes X-ray irradiator, ion chambers and electrometers, monitor chamber. The SSDL diagnostic level calibrates equipment used in the X-ray diagnostic facilities, which includes patients, dosimetry equipment, and diagnostic X-ray quality control equipment. Some of the major equipment at the therapy level SSDL includes gamma beam X200 irradiator, thermometers and barometers, ion chambers and electrometers, strontium 90 check sources, water phantom, PMMA solid phantom. The SSDL therapy level calibrates about 10 ionization chambers per year. The ionization chambers are mostly used in radiation oncology facilities for establishing dose to patients for cancer treatment. Other SSDL service includes irradiation of plant and animal samples, irradiation of TLD chips, cards and powder, irradiation of seeds and seedlings, irradiation of cultured specimens, spores, and other research material. The institute conducts wipe tests on sealed radioactive sources to evaluate the integrity of the radioactive source shielding material for industry using plastic scintillation canting coated with zinc sulfide. The institute also carries out quality control on radiodiagnostic equipment, which includes conventional X-ray machine, mammography machine, and computed tomography machine. Equipment in the institute for quality control are KVP meter, collimator test tool, beam alignment test tool, phantoms, wedge, focal spot test tool, aluminum filters, ion chamber, etc.
Welcome to the Environmental Monitoring Laboratory of the National Institute of Radiation Protection and Research located in the University of Ibadan. What do? We provide accurate and precise analysis results to the various clients served by our laboratory. The Environmental Monitoring Laboratory of the National Institute of Radiation Protection and Research maintains its high standard of excellence in analytical measurements by participating in interlaboratory quality assurance activities with the International Atomic Energy Agency, the IAEA. Who are our clients? Our clientele is drawn from the oil and gas industries, mining industries, exploration industries, excavation sites, researchers, and students from various tertiary institutions. What kind of samples do we analyze? We analyze environmental samples such as soil, sediment, and water, food samples like fish, milk, vegetables, etc. We also measure radon and thoron in air. Sample preparation. Materials and equipment used for sample preparation includes measuring cylinder, weighing balance, laboratory sieve, mortar and pestle, oven, methylated spirit, cotton wool, and marinelli beakers. For water sample preparation, measuring cylinder is used to measure 500 ml of water into the beaker. The samples are then sealed. For sediment and soil samples, laboratory oven is used to dry wet samples. Mortar and pestle is used for pulverization. The laboratory sieve is used to homogenize the samples. The samples are then weighed into the beaker using the weighing bar. Important to note that all samples prepared are air sealed for 28 days to attain circular equilibrium. And also, cotton wool and methylated spirits are used intermittently to disinfect the tools used during sample preparation to avoid cross-contamination. What are the standards used for analysis? We have standards of different geometries and matrices. Each standard used corresponds to the sample that is to be analyzed. Both standard and samples are counted at a preset time using the same detector. The standards available in the laboratory are IAEA 315, IAEA 448, IAEA 385, and Canberra NGS 6M315. What are the radionuclides of interest in the samples we analyze? There are artificial radionuclides such as cesium-137, cesium-134, and strontium-90. Also, natural radionuclides such as potassium-40, uranium-238, and thorium-232. What are the detectors in the Environmental Monitoring Laboratory? There are high-purity germanium detector, broad energy germanium detector, sodium iodide coaxial detector, sodium iodide well type detector, alpha spectrometer, liquid scintillation counter, that is the LSC, phylum radon monitor. The high purity germanium detector with a high resolution uses liquid nitrogen for its cooling and GNA 2000 software. Sodium iodide coaxial detector is a scintillation detector with a very high efficiency. The liquid scintillation counters are mainly used for counting beta emitting elements like tritium, carbon-14, strontium, etc. because their radiation, that is charged particles, has a short range in solids and liquids. The alpha spectrometer is a radiometric analytical technique for the qualitative and quantitative determination of alpha emitting radionuclides in samples. Samples are measured following chemical separation and purification, source preparation, and counting. Finally, the acquired spectra are analyzed using GNA 2000 software. Phylum model ABS portable radiation monitor. This is a monitor that has a wide range of modular assemblies which can be used to measure radon and thorium gas, airborne daughter products, surface contamination, gamma and X-rays. ABS with its accessories can measure radon gas concentration in homes, offices, buildings and mines, typically in picocurie per liter or becquerel per meter cube.